We're going to use this Pevono PS305 DC power supply on our model railroad, hook it up to our command station and some other things to see what we can do with it. I'm Tom Kovichak, and this is Tom's Trains and Things. This channel was created to help other modelers who are in need of guidance in pursuing their dream of building a model railroad. Now, every once in a while I get some questions from viewers about what power supply to use with this, and I just came across this one here, and I have to let you know that this is a paid product placement. My command station is a Digitrax DB 150, and it takes anywhere from 12 to 28 volts DC, and this power supply goes from 0 to 30 volt DC. It has a constant voltage on it, and it has a constant current on it, so you could do projects on your bench work. So first thing we're going to do is see what this does with the command station and see how the amperage is on our command station and try a couple of tests on there. Before I hook this up to anything, I want to give you a little rundown of the features of this. Now, this is a 0 to 30 volt DC bench power supply, and it will handle up to 5 amps. Now, right now I have it set for 19 volts because that's what I'm going to be using on the command station. But you'll see you have the voltage adjustments right here up on the top, and this is the coarse voltage and this is the fine voltage. Now, once you get close to whatever voltage you want, you could dial it in and use the fine one to pinpoint it down to the actual voltage that you want. Now, this is a 3-digit display. They also make a 4-digit display, which is a PS305H, and I have the PS305. Now, down here is if you want to use this as current limiting. Now, to start out, we'll just keep this up, you know, maybe about halfway, so we have some current on there, and I'll show you how to do the current limiting here in a minute. But anyway, we have the 3 terminals right here. We have our positive, we have our negative, and we have our chassis ground. If we're using any kind of components, testing any kind of components, and we're opening it up, we would hook this green to the ground of the component that we're using. But anyway, this is the positive, negative, on-off switch. It has a fan in the back, which will, with under load, it will operate depending on the load. Now I'm going to show you how to hook this up for current limiting. And so what you do is you hook up your test leads on there and ground them together. Turn it on. I'm going to bring this down pretty low. Okay, let's see if we can bring this down to about, well, that's about as far as I can. That's on the course. So I'll bring it down to 0.2 amps on there. So that's how you set the current limiting on there. You short the 2 leads together and you set it in there. I have this hooked up to my multimeter, my Fluke 111, and we're going to just test to see how close this is. Okay, now this is set to 19 volts. We'll bring this up to the voltage, DC voltage. Now this is a 4-digit display. This is a 3-digit display, so you're going to see a little bit of difference here. But anyway, we'll bring this one up on the fine adjustment. And now we have 19.1 and we have 19.09 on that one. So that seems to be pretty close. We'll bring this down on the course. We'll bring it down to about around 12 volts. and then dial this in to 12. So we got 12 on here, 12.01 on there. So that looks pretty good. It's pretty accurate as far as the voltage goes on here. Now I have this hooked up to my Digitrax DB 150 command station. We'll turn the power on here, and we'll bring this up to 19 volts. And if you use one of Digitrax power supplies, it has a selection on there for 19 volts. It actually has 1, 2, 3, it has 7 different selections on there from 12 volts all the way up to 24 volts. Now the DB150 will handle 12 to 28 volt DC. Now as you can see, with no load on there, it's 0.13 amps. Now it's in standby mode right now. So let me put it in run mode, and you can see it goes up to 0.2 amps, and that dropped the voltage down because it's on the current limiting. I limited the current on it. Okay, let me bring the current back up. All right, now we're talking here. I had the current set down for the on the last test, so bringing the current back up, it brings the voltage back up to where I wanted it. So we got 0.25 amps on there. Now I have the command station set at N scale. And as you know, you could have 3 different settings on there for O. I won't go that high, but I'll go up to HO and see if it changes the amperage on it. It just brings it up slightly. But what I'm going to do is I'm going to run the locomotive on here. I'm going to put power on the tracks. And I'll bring this into view here. Okay, I got power on the tracks now. And I'll run this one in reverse. And as you can see, oops, I'm running it forward. The amperage goes up on there. Now let me reverse this. And I'll bring the throttle up over here. So the amperage stays down pretty low whenever we're doing that. Let me reverse the direction on there again and then crank this way up. Now the reason I'm stopping it right there is I have my test probes on there. Okay, one thing I'm going to do, I'm going to turn the meter on. Now the signal going to the tracks is actually an AC signal, and it's 11.9 volts on there. I'm going to turn this in the opposite direction, and we're going to take a look at what happens there on the DCC signal and the DC going into the command station, what it draws on there. Okay, now one thing I wanted to do, this is, I have the switch on N scale right now. So let me drop it down to HO scale. And you're going to see an increase in the voltage going to the tracks. Now it went from 11, whatever it was, up to 14.39 on the tracks. Now, if you're running any of your components, like the PM42 runs off of the a separate power supply, you can run your DS64s on track power. Now this is where this comes into effect, your N scale and HO scale, where you want to determine what your voltage is going to your DS64 if you're using the track power, because if you had it in N scale, it would bring it down to 11, and if in the HO scale, it brings it up to 14, almost 14.5 volts. Now, the reason for that is whenever you're moving your tortoise switch machines with the DS64, but when you move them, I have them on a different power supply right now, but depending if you are using the track power on here, that would determine how fast or how slow that they go. But let's run this again. This is on HO. And as I increase the speed, the amperage goes up. And you can see it doesn't draw that much amperage with just one locomotive on there. Now I had that up to 32 on there, and it, so coming back it's on 50, and you can see it's still only 0.4, and I just ran over my probes. It didn't stop fast enough. Okay, I just shut the power off to the tracks, and then I'll put this in standby mode, and you can see the amperage drops on there. But that's how this operates with the DB150 command station. Now you could test this out on the bench to see where your optimal performance is with your command station while you're using it. This little power supply is going to come in handy on my workbench and on my model railroad. Now, with 5 amps of power, do you realize how much you could run on your layout with this? Now, one thing, it's going to have to be the same voltage. So if you have a lot of different components on there that you need to power up, say with 12 volts, or say with 18 volts, or say with even 9 volts, you could use this on here. Just to give you an example, using a wall wart for a tortoise switch machine rated at 12 volts and 1 amp will run 30 tortoise switch machines. This is 5 amps right here. So imagine how much you could operate with this little power supply right here. I'm not saying you could run, you're going to be running 300 tortoise switch machines with this unit right here, but that just gives you an idea of how much 5 amps will run on your model railroad. So this is going to be, I'm going to be using this in a couple of more videos. I'm not going to be highlighting it, but you're going to be able to see this in the background, me testing stuff and me using it on the model railroad and on my workbench. For under 60 bucks, you can't go wrong with this. You can't find another power supply for your workbench lower than this with this kind of quality. Now, I've seen other videos where they took it apart and they showed you inside. I'm not going to do that here, but you could take a look at the other ones. I have some links down in the description of where you could get this on Amazon. And don't forget to check out my other videos, and we'll see ya.